everybody, welcome to another Science at Home. Today we're going to be doing baking soda rockets. So what you'll need is some baking soda, some vinegar, a bottle, a few straws or pencils that you will tape around, just like you see here, making kind of a tripod that will hold the bottle up on the ground like this. And when you do this, you want to make sure that the nozzle is pointed down. Now you will also need a cork, a paper towel, and again a funnel and something to scoop in. Now, very important, this should be done outside. Do not do it inside. Somebody will likely get mad at you for that. But to start off with, like I said, you want to make sure you have a nice empty bottle and tape some straws or pencils around it to create a sort of base to hold the bottle up off the ground. Now, for your cork, you want to make sure that it's a nice snug fit in the neck of the bottle. If it's not, you can wrap something around it like ribbon or a rubber band to give it a tight seal. But the seal is very important for the bottle. So next up, we're going to pour some vinegar into our bottle. Now, amounts in this experiment aren't really that important, so go ahead and pour some in. I'm gonna do maybe about a third of the bottle or so of vinegar. There we go. Next, you want to, a little windy here today, you want to spread out a bit of napkin or paper towel and scoop some baking soda into it. And again, it doesn't really matter amount-wise, but it's important to make sure that it's an amount you will be able to fit through the nozzle of the bottle. So to help with that, what I'm doing is I am spreading the baking soda along in a line, long ways on the paper towel. And then, maybe I'll try adding just a bit more, and we'll see if I can get it. But now I am going to roll it up, kind of like a burrito. I'm gonna pinch in my ends here and just kind of roll it up long ways, just like a burrito. All right. I'm gonna go try and get it a little bit tighter here, just because I know it can be tricky getting it through the neck of the bottle. And we're gonna wanna kind of try and do that part as quickly as possible. So once I insert this into the bottle, that is when we're going to shove the cork in the top and flip it upside down. And we're gonna have to be kind of quick about it. So I'm explaining it now. And I might just take a little bit of this baking soda out. It's a little bit of trial and error that goes on with this. But I would rather be able to get it right in the rocket. And as always in science, it's okay to experiment. It's okay for things to not work out right the first time. That is part of science. And there's no failing in science as long as you get a result. So I'm gonna go ahead and try and stuff this little guy in here. It's a big guy actually. This is the part where things can go a bit sideways. I want to make sure to get my baking soda in there, but I also want to make sure that it stays in that paper towel as best as it can. So bit by bit, it is going in, I promise. This is not the most exciting part maybe to watch, but the danger of it going off in my face is very real. So it's a little suspenseful on this end. Now, once I get the cork in, I'm also going to want to move out of the way quickly so that when it does go off and shoot, I am not in the path. All right, last little bit here. See if we can get it. Smush a bit. All right, shove my cork in. Get my bug. And that is part of science. Like I said, as long as you get results, there's no failure. But that is the importance of trying to do this quickly. So as you can see, I did not get out of the way quick enough. But let's talk about what happened. Got a little vinegar in my eyes. It's okay. So essentially what happens is the paper towel acts as a little bit of a barrier between the baking soda and the vinegar. Now that barrier gives you enough time, should give you enough time, to put the cork in, stand the bottle up, and move out of the way. Now, mine didn't quite work that way, so make sure you're careful when you do that step. But when the baking soda and vinegar mix, it creates a reaction that creates a gas. Now, the gas builds up inside the bottle. Remember we talked about how the cork needed to be a tight fit? That is so the gas can't escape. So once the pressure is built up so high in the bottle, the cork is forced out. Now, that force of the pressure, it creates a force. Now, this is kind of where we're going to get into Newton's laws of motion. Every action has an equal reaction. So, the force of the gas gets funneled out of the nozzle of the bottle. And it pushes against the ground. Now, it can't move this ground here. So what happens? The bottle moves up instead. Now, the bottle isn't going to move until it has enough force to move it. So that's when you see it shoot up. That's why there's a delay. Something doesn't move unless it's being forced to. Now those are Newton's first and third laws of motion. What about the second? Well, the second one basically comes down to the heavier an object, the more force it needs. The more force you use, the more an object is going to move. So that's where playing around a little bit with different size bottles, different amounts of vinegar and baking soda, or even just using different materials to pop up. Make it heavier, have more ingredients to make a bigger reaction, see how that affects it. But, as you can see, we made a little bit of a mess, and that is why we're doing this outside. But again, it's okay to fail in science. Failure gives you results, and you learn from the results. So it's never a loss when something doesn't go your way in science. So thanks for watching, guys. I hope you have fun with this one, and we'll see you next week.